So what we'd like to do here is to give you a brief introduction about Kubernetes. This is definitely not going to be an in-depth technical training, because with 45 minutes, that's not going to be working. Miguel was doing, together with Flavio already today, if I'm not mistaken, hands-on training on Kubernetes. I'm not quite sure if any one of you was attending that one.
And tomorrow there's going to be another one.
So in case, if that's what you're looking for, please feel free to visit them. What we're planning to do here is something slightly different. That is, the assumption is many sysadmins are now confronted with the containers paradigm and with Kubernetes. And often enough, there is not enough understanding of what the hell this is all about. So what we would like to do here is to give you enough elements, enough basics to go out and start looking at it for yourself in case you're interested, but still being able to understand the basic terminology, trying to, having a little idea of how the whole works so that you're afterwards able to build on your own opinion. That's pretty much what we're trying to do here. All right, so do we have a clicker? Oh, well, can do like this. So what we would like to start with is a different story. That is the story of a developer that is there. He's a brilliant developer and has many innovative ideas about how to build his own application. And he's there and he's trying all the new technologies and all the cool things. And he actually finds the moment in which he thinks, yes, this will be so perfect like this. And he starts developing his application and then basically goes to the operation side of life and gets confronted with quite a series of restrictions that he has. So maybe the technology is too bleeding edge, cannot be used. Maybe there is a conflict in what is required from the platform side of what they need. Maybe, simply it just needs to find a point in the middle with all the other applications that are actually needed in production. And this is quite normal, and this is quite right, but this also creates some sort of frustration. And this frustration is one of the things that is behind containers in general. Developers wanted to have something that would allow them to be a bit more free in what they were doing, to use the right tools for the job, and to basically, being able to concentrate on developing an application more than be bound by all the rules and the bureaucracy that is behind, let's say, in the data center side. This doesn't mean that what we're trying to say here is that the application side should be completely unregulated. That's absolutely not the case. But there are a couple of things that could be made simple. And this is, why a developer may be interested in Docker in the first place, or containers. So let's say that this developer decides to keep going with Docker and starts creating the first application. You would see that in the end, it doesn't really matter what's on the base OS that his application is going to run into. He's going to be able to move this application around. He's going to be able to, basically have exactly the same environment on his laptop as it is in production. So the runs on my laptop story is not really, let's say, the beginning of tears and sleepless nights for everyone. Actually works. And is also able to, for example, have even things like old and new version of the same application running on the very same machine without any kind of restrictions from, let's say, the upside. But it's also true that once you start with one container, you hardly want to remain with just one container. You may want to keep growing and creating more and more than this. So basically moving towards what is a microservice, let's say. And this could create quite some problems, let's say, at least on the upside. Because while from a developer side, once you get into what a microservice is, you may have some time that is needed for you to start creating the architecture in the first place, but then you're more or less set and fine to go. But for an operator perspective, this starts with quite some additional problems. That is, yes, you have to learn Docker as well, but you have a huge series of problems that you will be confronted to. That is from how am I going to handle all the log management on those containers? How am I going to do monitoring, security, networking? All these issues are going to be there and waiting for you. The developer doesn't really care much about this anymore. I mean, he made the application, handed it over to operation and says, now you run it. And so it looks almost like we are trying to move the heavy lifting part from the developer and pushing it towards operation with containers. That's one of the main impressions that we may have. But that's not necessarily true. What I mean with this is that, well, let's call it in a slightly different way. That is, it doesn't really matter if you have containers in this specific case. You would have exactly the same kind of problems with all kind of distributed systems. So may this be virtual machines, application in a high available environment, load balancers, doesn't really matter. It's exactly the same set of problems. The main difference that you have is that you don't have, at the moment, the right tools for the job, or at least the tools that you have been using so far are not going to be able to handle containers in the very same way in which they were handling your virtual machine before. So you have basically two choices. You can decide if you want to start just using exactly the very same tools and adapt them to be able to handle containers, or if you want to look at what is already there available for containers. And yeah, if you really want to start reinventing the wheel, that's mainly up to you. But our suggestion would be not to do so and try to leverage instead on an orchestrator that is something that not only has the intelligence of deciding when and how your containers are going to run or where, but also to give a set of answers for all the problems that we saw before. So if we're taking something like Kubernetes that is often, and I guess Miguel will use this term as well, referred to as an opinionated solution. Opinionated may have some sort of negative acception in the term, but what we're trying to say here is that Kubernetes offers already answers for basically the problems that you would have otherwise to solve on your own. So that's a box that comes with basically many little, how to call that? Yes, with defaults, with ways of doing things that maybe if you would have had to look at the problem on your own, you would have probably picked something else, or maybe the same. That's mainly up to you. But Kubernetes offers you a way to solve those problems out of the box. That's what I'm trying to say. And yeah, as I said, you can decide to do everything on your own and go through this. Yeah, okay. That's what I wanted to have again. Okay, and go through all this. You're completely free to do that. In the end, with Docker, you are starting with absolutely nothing. All the rest is up to you. Or you can say, OK, I don't want to spend my time in taking care of things that I've already been looking for the last 20 years. I trust that, in this case, Kubernetes, with its background, is going to be able to do this for me. And I will, let's say, let Kubernetes sort my own problems. So this is one of the reasons why we decided to go for an orchestration solution also from the SUSE side. We had Docker out in the containers module for over 1.5 years, yeah, if I'm not mistaken now, yeah. But was only the Docker daemon, so obviously the images and the registry and all those kind of things. But there was no orchestration whatsoever. We thought that if you want to get out of this single box use case and actually start using Docker, you would need something to help you going through all that learning cliff. And that's why, yeah, we decided to go for Kubernetes, even if there has been a very long research project on the different orchestration solutions that were available at that time. But OK, enough of me. I would say that it's time to talk a bit more about orchestration itself. So I will hand it over with.
I wanted to check whether that.
You need to plug in the stick, which is in the back. I will show you. Give me that. Oh, it's over here.
All right.
Now plug in this.
I get the uncomfortable part of the presentation, I see. That's fine.
Whoa, that's so fancy. So yeah, as Federica said, this is not an in-depth introduction into Kubernetes or into the dirty internals of Kubernetes itself. But in order to realize what we're dealing with, we need to check more or less what is Kubernetes and give an overview of it and give an overview of the architecture so we can more or less understand what's supposed to be a deployment of Kubernetes. So first and foremost, of course, it's a container orchestrator. That's all we want. We want to orchestrate multiple containers that might be running on different nodes, that might might be running on different networks and all that. And so Kubernetes does that in a very organized way, as we will see. Of course, it's open source. We have this in our genes. We love open source. We love free software. So Kubernetes is open source. It's based not on some Google engineer that had this brilliant idea one day in the morning. No, it's based on rock solid papers. It's based on some research in papers that have been very well thought out and all that.
And
so,
I mean, I guess we can say that Google knows how to run distributed workloads.
Exactly.
At least that's pretty much.
Exactly. So yeah, and as Federica said, it's an opinionated solution. So you can have it. I guess that to tackle one problem, you can go in two different ways. You can have the library approach, maybe, as in you can grab different parts that solve parts of your problem and then go on with it. Or you can go the framework way, which is having a uniform way of tackle most of the problems. That's the Kubernetes way. It has an opinionated way of dealing with how you schedule containers, how you handle secrets, volumes, the networking, all that. So all that is taken care of for you. I put the Google engineer example because it was created by Google, as some of you may know. That being said, it's no longer part of Google itself. Rather, it's part of the organization CNCF, which is part of the Linux Foundation. And there's multiple companies like us, Red Hat, and whatnot working on that. It's a big and active community. You can go on GitHub and see the stars and forks and all that, but it's not about that. It's about the mailing list discussions that there are, the multiple requests for changes that there are, and all the discussions that come up with that. So it's a very active community. Once you dive into it, you will realize about that. And so since it was produced firstly by Google with all the experiences that they had in their clusters, we can fairly say that it's battle tested in real world production. I mean, with Google, we're talking about hundreds and hundreds of nodes with tons and tons of processes running there. So yeah, it's cool, this pointer thing. So
New technologies.
Yeah. So we thought about giving you an overview of the architecture of Kubernetes, and so we could go on with like this big image and try to explain each piece on the graph, but we thought that it would be better to go like bottom up. So we start from the very basic, which is a container. A container, as you may know, it's the application itself, the process itself, and its required environment, file system, and other metadata that might be needed. The whole point of containerization is to isolate this process. That is by providing Linux kernel namespaces with networking, the file system, and all that. So, okay, that's the whole point of containers, but of course this brings some challenges, like how do you do load balancing? How do you connect all these different processes that are deployed as containers? How do you manage storage? Because once a container disappears, the associated file system gets removed. So how do you handle that? And yeah, this is the most basic unit from the Kubernetes point of view. But even that, Kubernetes offers an abstraction on top of containers, which are called pods. And pods are the basic runnable unit of work. And so in Kubernetes, you do not manage containers, you manage pods. In a pod, you can have one single container, but you can have multiple related containers, that's fine. And yeah, Kubernetes, when you deploy containers in a pod, the associated network of the cluster environment gets hooked into pods, so pods can talk to other pods through the cluster environment. We will see more about that.
There's a question there.
Yeah.
Containers. The basic LXC containers or
Docker containers.
Docker?
That depends though, because I'm saying Docker because that's the default, but as we will see later, the runtime being used can be Docker or can be Rocket, or there's also alpha features to include the new OCI tool, runC, in there. So the runtime engine is actually separated from it. We will see that in the global picture. And so I've talked about pods, but how do you make sure that there's always a number of pods being run? That is done by the replication controller, which is a process that lives in the Kubernetes master. There's a node in your cluster that is going to be the Kubernetes master. And in there, you've got the replication controller, which makes sure that there's this amount of replicas, as it's called, which are pods. And so there's a number of replicas always running on your cluster.
So Miguel, what you're saying here is that you actually have a state that you're declaring for the cluster to be.
Yeah. So the way Kubernetes works from a sysadmin point of view is that you declare what is called a manifest, in which you declare the state of your cluster. And you declare that I want exactly this amount of replicas being run. And so Kubernetes makes sure that this happens.
So that means that I can also do nifty things like, for example, I need just one pod to be replicated because, for example, I don't know, I'm expecting more load for that specific service, and basically instead do not scale the rest of my services there, right?
Yeah.
Okay.
Exactly. And so besides that, in the Kubernetes master, there's also the API server. This is the process in which administrators will target, because the kube control tool that administrator will use will target the API server. And so with kube control, you will be able to perform stuff like, I want to get the pods that are running, I want to create a new pod, I want to create a new service and all that. And so I just talked about services. So what is a service? So the main idea is that pods come and go. They have a very volatile life cycle, because you can scale up your application, that is creating new pods, or you can scale down, so actually killing pods, or you can move pods around. The idea of service is that even if pods come and go, services don't. So pods can have this IP and this port for now that it's running, but maybe it gets killed and it gets rescheduled in another node, so it gets another IP and all that. You don't want to get track of all that. So Kubernetes brings this abstraction, which is called service, which guarantees you that there's going to be this exact IP, this exact port that you can contact, and you will be contacting that service. So if your service is about 2 pods that are running in different minions, you don't care about that. You don't care that there's this minion, this pod running there and that other running there. No, you care about service B, for example. And so in this picture, you are seeing what is the Kubernetes minion, which is the worker. And in there, as you said, the runtime is Docker, but you can change that with Rocket, or you can change it with other experimental features like runc and whatnot. There's also the kubelet, which is the one that guarantees that this pod is going to be created. It's the one that runs containers and runs pods, creates pods. And then there's the kube proxy, which takes care of all the networking. So if this container, let's say of service A, wants to reach the one from service B, it will go through kube proxy, and kube proxy will have its own way of routing into maybe another host, or it depends. So this, through kube proxy, is the way of doing, and services are the way of doing an integrated service discovery.
So Miguel, given that, I need to simplify things here as the project manager. So does that mean that a service is a bit like a switchboard operator? So something like, someone that is there waiting to receive my call, and then basically just connects me to the person I really want to talk to. And I really don't have to care about where the person is at that very moment.
That could be a very valid analogy. Yeah. You can think of the good old times when there were phone operators connecting you through switches. That would be your service. And so, yeah. Besides that, then we can go on with, okay, it's cool that you can run multiple containers and all that, but I want to store all this data. This is done. Oops.
That's me, sorry.
Okay. So this was not done by Kubernetes. So then you've got the idea of volume. So you want to store all this data that gets accumulated by your services. So maybe it's a database application, database. So if I store data, I want to be there even though my pod disappears and restarts, and I want this data to persist. And that is done through volumes, which is an abstraction. in which you can define which storage backend you actually want. It can be in your local file system, but please don't do that. It can be on an NFS server. It can be in Ceph. It can be in, I don't know, in Gluster. It can be in any other storage backend that you can think of. There's a lot of backends available. And so when you define in your manifest the pod, you can declare that you want your pod to access this NFS server or whatever. So you can claim this volume in order to persist data.
Is it always a file system you're storing it on, or store it on Unix as well?
You don't necessarily care about that.
You want to repeat the question? That was very, just because you have the microphone. Just repeat the question.
So the question was whether it's stored in your local file system?
No, it's like when we're talking about backend storage, it could be a file system that is supposed to be a file system, or
it doesn't have to. So it can be in your local file system, but that would be not really production ready, because if that node goes down, I mean, you lost your data. It can be a Ceph, so you point the URL to your Ceph application, or it can be NFS, so you just point to the NFS server, the URL of your NFS server, and you define the path to be stored at.
But you're still talking file system. I'm on the storage team.
In NFS, yes, but in your application, you don't. You just simply say that you want to store this data into this backend, and how this backend handles the data, you don't care about that.
Honestly, I don't think you can do that directly with images. Probably there are ways of doing that, but nothing of the most common backends. Yeah.
Yeah, no worries.
But yeah, actually, sorry, at this point, it's actually nevertheless very interesting what you were saying. That is, from the container's perspective, this is completely transparent.
Yeah.
So basically, a container just sees whatever chunk of storage you attach to it as part of the local file system.
Exactly. This is done transparently. So as a container, you don't really care how this will get stored. You just it's just right there. And so another concept which is pretty handy are labels, which are really open-ended. You can create tons of labels and use them and give them meaning as you want. This is usually done, for example, to select services with their related pods, but it can be done in by any means. I mean, it's really open-ended. You can use them. You can use them whatever way you want. Another handy concept are namespaces. This gives a bit of multi-tenancy, not real multi-tenancy, but about separating the workloads on the same cluster from different users. So let's say that you have this team that pushes onto this namespace, so it won't clash on other namespaces on the Kubernetes cluster.
But Miguel, can you tell us if those namespaces are the same as, for example, for Linux namespaces or
Linux namespaces?
kernel?
Oh, right.
User
No, of course
networking?
not. It's not the same. Linux namespaces, we're talking about the operating system itself. The namespaces you can think of like in programming languages, for example, that you don't want the names of classes or functions to clash with other parts of your code. It can be thought like that. And so this is a global architecture. Here we have multiple minions which are running the different pods. There's 2 services here. Services can have pods in multiple minions. That's not a problem. The kube proxy will take care of the networking part. The kubelet will use the runtime engine Docker to create new pods and new containers. We've got the Kubernetes master. In there, there's only one, but there can be multiple of them. And take photos if you want. And so, yeah, in the Kubernetes master, here there's only 2 processes, the replication controller and the API server, which I already talked about them. But there's also the scheduler, of course, which takes care of scheduling pods into the different nodes. And yeah, so you've got all these nodes. There might be 100 of them, 1,000 of them. You have all these processes. And I didn't show it here, but there's also there should be an etcd cluster, which is the key value store that in Kubernetes is going to persist data about your cluster, where your pods are and all that. So okay, how do you deploy that? So it's here I'm a bit ironic, so it's pretty easy. As in, you just have to install the right certificates in the right nodes. You just
in the right order.
In the right order, of course. You have to install, configure all these packages like etcd, all the Kubernetes binaries, kubeproxy, kubelet, Flannel, which is the networking stack that we're using, the Docker runtime engine, of course. You have to, write the proper configuration for them. There's really inner details that you have to spend countless months of hours to really understand what's going on there. So you've got this total of 5 configurations for each master plus 4 for each minion. You have to spend hours reading getting started guides because, okay, there's really more to it, and you really have to spend a lot of time understanding all this. And
so that's basically what happens when you're leaving the deployment strategy left to developers, right?
Yeah.
Okay. So the main problem that so first of all, little parenthesis here. We have 2 completely different backgrounds. I'm coming from a system administration and support perspective. He's a pure developer. So opinions here may differ. In my opinion, the upstream guides are very detailed, but they're not targeted to sysadmins. They are developer guides. So this doesn't mean that you're not going to be able to install it, but it also means that it could take you a very long time and many attempts before you get something done properly. I can mention that in one conversation that we had with some of our customers that were trying to deploy the upstream version of Kubernetes, thank you. It took them the first attempt before they had something working over 8 days, just to have something to start with. And that's, at least in our opinion, something that it could be definitely done differently. So you could see nowadays that upstream, they are trying to work a little bit in this direction with something called kubeadm, so admin. And that's a very good start for the problem, but to solve the problem, but it's definitely not there yet. And this is basically where we decided that we definitely need to give quite some contribution to change a bit the situation under this perspective. So basically, we're working on 2 different sides on here. And the first step, that is going to be the one that is going to be visible for everyone in the next month, I believe, that is going to be to use Magnum, that is an OpenStack component, to do Kubernetes deployments. By using this plugin, the previous customer actually managed to deploy the Kubernetes cluster within 7 minutes with having an application running. So from the 8 days to 7 minutes, that makes a bit of a difference. It's true, this runs on OpenStack, so the solution is pretty much locked into OpenStack, but there is quite some demand around having Kubernetes running in OpenStack anyway. So that's one of the possible option. And the other one is what we are currently working on, that is the SUSE Container as a Service platform that is targeted to be available outside of OpenStack, so working on bare metal, but also virtual platform. So may this be just your virtual machines, but also public clouds. And that's what Thomas Di Giacomo was mentioning today during the keynote. So the idea here is a bit different. While Magnum is something that takes Kubernetes, knows how to set it up, and basically just creates separate virtual machines for all the components, and this actually gives you true multi-tenancy, thing that you wouldn't have with a single Kubernetes cluster. With SUSE Containers as a Service platform, what we're trying to do there is to have a different type of operating system. You will see that this is not going to be a pure SLAS. It's going to have quite some differences. And the point here is to have something that is purely tailored to be the base for Kubernetes. So it's not just a stripped-down version of SLAS. It's not a juice plus Kubernetes on top. That's not the case. It's something completely different that is done in order to allow us to fully take the best out of Kubernetes once it's deployed. we are not looking at this as the pet as SLAS is. So we are taking this in consideration with a system of several nodes. So this is meant to be part of a cluster. And that's a very different starting point than what we have normally with SLAS and trying to adapt SLAS to run those type of use cases.
So it's more like CoreOS?
Something that goes in that direction, yes. And we're planning to have a completely open beta for this one end of March, and to have the first shipment July of this year.
So each task itself would be based with the master image.
Correct. So basically what we are planning to do there is to have one single ISO. That is basically the starting point. You would go through a very simplified installer, so much shorter than what you have, for example, now in SLAS, only to get the very essential information that you need from the Kubernetes perspective. And basically this one will, after that, generate AutoIaaS profiles that are going to be used automatically to bootstrap the rest of your infrastructure. This also means that what we would like to have is quite some intelligence in terms of realizing how many nodes are joining the cluster, so that it's something that you will be able to modify, but we would like to give you same defaults. So we would like to give you suggestions of the type of nodes and roles that you need within this cluster based on the amount of nodes you're putting in. This is something that you can modify within the boundaries. I mean, obviously, you need etcd, so you can't say, like, I don't want etcd at all, because it's a necessary component for Kubernetes. But we would like to make this as streamlined and as easy as possible, because the idea behind this is that you shouldn't spend days, but not even hours, trying to bootstrap the Kubernetes cluster. You want Kubernetes because you want to run applications on this. So yes, this will also come with maintenance windows and automatic updates. We will also look at having Btrfs snapshots in read-only mode for the active one, so that basically we can have transactional updates at the same time. But yeah, I mean, if you're interested in this, please come and see us at the tech showcase, and we can definitely talk a bit more about this. And I think that's pretty much it.
Yep.
Do you have any questions?
Yeah, where does JOS fit in? Is this more or less the price for the doctor?
No. So JUICE, I don't know why it's pronounced juice. I really don't know. But anyway, so JUICE, it will stay where it is. It's a different use case, so it's a multi-purpose operating system. What we're trying to do with that is something that it's only for Kubernetes. So you will still have, for example, for embedded systems, the need of having a JUICE-like kind of OS, so something that is very small, but that you can customize depending on what you need to do. In this case, it's something, separately. And regarding the Docker images, well, obviously we started back then when we looked at it with JUICE, but nowadays the base images that we have very little to do with JUICE. Basically, it would be more correct to say that those base images are a zipper image, more or less, because there is nothing else but what you need to run zipper inside so that you can eventually install something extra.
On your menu, so you actually have access to other hardware that is accessible to the pod. We did a disk drive structure, because I'm assuming we're putting a very basic image to run Kubernetes. And really, I know the main use case is running applications. Of course, I'm over at Subland, people have ideas. If I was in a container inside a pod, would I be able to do some configuration to access this?
Well, you should be able to anyway to access that local storage.
Yeah. Right. So you will have to claim a volume with that, a persistent volume. But if you're trying to do that on your local storage, you will only be able to do that on the only writable path in the microOS CASP host.
Because the thing is, on the Kubernetes perspective, it doesn't really, you shouldn't care where you're running your job. And that's probably not what you want. Is any one of you planning to play around with Kubernetes?
I'm a cloud foundry guy.
Do you hate us?
Not yet.
I heard that SUSE is planning to build Cloud Foundry on top of Kubernetes. I was skeptical at first, but now it makes more sense. Because I'm going to sessions where they talk about it, and since if you're using Kubernetes to manage your containers, you don't want to learn Bash or something out of Cloud Foundry to do the same for your apps. So it makes perfect sense to combine them to set Kubernetes does pretty similar things to what the Cloud Foundry does. So I like that.
Let's see.
Yeah, let's see. Let's see if that works.
We all know as much as you do, so. All right, so I would say that we are done. If you want, feel free to pass by Miguel's hands-on tomorrow, or otherwise just pass over at the booth and you can play around with Kubernetes if you like.
Thank you very much.